Okay, my name is Kathleen Shanti Anapita. Metric number is CN210229. The abstract is tower crane is one of the heavy machinery that normally used to lifting and moving the stuff material that on the to the place of height. The method we use to handle of this tower crane to stabilize the crane prevent to fall is analysis crane thrust to maximum the load of arm. In this study, to provide completely stability to prevent the crane tower to fall.
First and foremost is introduction. Tower cranes are used in building projects, especially in highly construction sites where work concentration is in a limited area. Counterweight is a weight that, by applying an opposite force, provides balance and stability of a mechanical system. Tower crane collapse because its counterweight is not enough to provide balance and stability of it.
I'm Bernabel. I'm going to explain about methodology. As you can see, this is shown that the situation before the tower crane collapse, and we're going to study the stability of the tower crane, which is the maximum capacity of the tower crane was 6,000 kilogram, and the length of the boom is 13 meter. And this is the calculation that we made. So we're going to find the tension, compression in each point when the tower crane started to collapse, when the load is moved along the boom, which is the 13 meter boom. And I'm going to do a comparison in the complete set of tower crane in order to overcome the tower crane collapse. So this is the components and safety that must have in each tower crane. That's all for me.
For these questions of tower cranes is find the force of BC and AC, and also we need to identify some zero force member. Assume hanging mass is exactly 6,000 kN. From point C, we need to calculate the weight of 6,000 kg with formulas 9.81, and we got 58.86 kN. From force Y equal 0, we find the FBC using 58.86 kN divide sin 40, and the answer is 91.56 kN tension. From force F equal 0, we find the force AC minus force BC cos theta equal 0. Then insert the answers 91.56 cos 32.85, and the final answer is force AC equal 76.91 kN compression. For finding the counterweight is 58.86 kN multiplied 30m. To find the WC, we using moment divide distance 6m, so the WC value is 47.8 kN. This is overload case. For finding the counterweight is 21.58 kN multiplied 30m. To find the WC, we using the moment divide distance 6m, so the WC value is 107.91 kN. For these questions of tower crane is finding the force of BC and AC. Assumes hanging mass is exactly 2,200 kN. For the point C, we need to calculate the weight of 2,200 kg with formulas 9.81, and we got 21.58 kN. From force Y equals 0, we find the force BC using 21.58 kN divides sin 14. The answer is 33.58 kN tension. From force X equal 0, we find the force AC minus force BC cos theta equal 0. Then insert the answers 33.58 cos 32.85, and the final answer is the force AC 38.21 kN compression. The maximum of the load is 47.8 kg. From this overload case show that the WC's value is overload when it's on the distance 30m. It was cause unstable of the tower's crane. In the study, the accident's occurrence is hidden with the overturnings of the tower's cranes in a construction site, and the damage occurrence on the nearby field due to this accident were taken into consideration. The accident has been analyzed, and the main reasons of these failures have determined as distance and the load would affect tower's cranes accident.
As we may have noticed, there are technical reasons that crane fall over, but there are also underlying human factors as well. It's best practice to create a lift plan anytime a crane is used. That involves taking the opportunity before the load is in the air to consider all the aspects of the lift and what could go wrong, such as the weight, the dimension, the center of gravity, lifting point of the load, the path it will travel during the lift, the capabilities of the crane, outside factor, such as wind and communication during the whole process. For complicated lifts, This plan can take days or weeks to prepare with detailed engineering review to ensure that nothing goes wrong once the load is in the hook.